Hey guys, this is Sick from Belva.io and I'm back with another Golang tutorial today. And today we're looking at a design pattern in Go called dependency injection. Now, dependency injection is a really central design pattern in Golang. It's used really in most best practice Go code, and it definitely is something that you should be doing if you're running a lot of Go code because it has a lot of benefits. And so for this example, I've created a really simple, stupid little game, and if we just run it, we can try running it. And what it will do is it will create a bunch of players, and then these players will play 3 rounds against each other. And we can see round 1 ended in a draw, and the second round, Attila the Hun attacked Vlad the Impaler, and he won. And then the third round, Caesar attacked Vlad the Impaler, and Caesar won the third round. And you can run it again. We can see now Attila the Hun is attacking Eric the Red, and Khal Drogo is attacking Attila the Hun, and finally Vlad the Impaler is attacking Caesar. So this actual little game is just a boat example, which doesn't really matter what it does, but the way it works, as you can see, all the way out here in the app.go starting entry point of the application, is it has a game client, which we instantiate, and a game client takes as parameters 2 things. It takes a logger and it takes a DB service. And this is really where dependency injection comes into play. So basically what we are doing is we are saying when we create a client, we need to have created, prior to creating the client, we need to have created a logger and we need to have created a DB service. And then the client, when we create it, will use that DB service and that logger. Let's take a look as an example what these different things do. So if we start with the DB service, this is a really simple Golang struct. It's basically just emulating a database, a very simple database. And the only thing it does is it keeps an internal map of string to string, and it creates unique identifiers for each of the names that we enter into it. And then you can use that unique identifier to get the name. And if you really want, you can get all the keys or all the unique identifiers that the database knows about. So that's all the DB service does. And if you look at this up here, this is using a consumer interface. If you haven't watched my video on consumer interface patterns, you should go check that out just now. It goes really hand in hand with dependency injection. And if you're looking at the new DB service constructor, it also takes a logger that it basically takes a reference to and stores it inside its struct. And this is really at the heart of dependency injection. So we're saying instead of each of these services, for example, implementing a logger, we'll have one type of logger, and they can even through consumer interfaces, each service can basically say what parts of the logger it needs. But we'll have one logger instance, and we'll pass it into all the things that might need it. And then they will keep a reference to it. That's what this line does. We're here. Logger keeps a pointer to a logger, right? And then they will use it in all their methods. And if we look at the client, which is, I guess, where the game is implemented, it really does the same thing. And this is where the dependency injection pattern is so strong. So basically, it uses consumer interfaces to say, in order for this client to work, it needs to have some kind of a database, which needs to know how to store names and get names. And it needs a logger that can write to debug and write to error so that it can do its logic, basically. And then we have a struct. And struct says, in order to use these things up here, I'm going to keep a reference to them. So that's these 2 fields right here, right? A logger pointer and a DB pointer. And then finally, it has some other state, which relates to the client itself that isn't dependency injected, but that is just state that doesn't relate to anything that's injected to it. And then again, crucially, the constructor of client takes a logger and a DB pointer. And in Go, you can actually just tell it that it will be of the type interface, and Go will understand that when you're pointing it in or when you're passing it in at runtime, it will keep a pointer to the thing you're passing in. And Go will also make sure that the thing you're passing in lives up to the consumer interface that you have specified up here. And so the way we use this is we pass in a logger and the database with a DB service. In our case, that's going to be implementation of it. And then we store a reference to it. And that allows us to actually go in and use these things inside our client. So then we've got an add players function. All it does, again, this is a stupid little game. All it does is it calls on the DB pointer that we passed in earlier to see the DB and calls store name. And again, remember, store name is part of the interface up here, but it's implemented in our database service, right? So the client doesn't really care. It just says store name is implemented and somewhere else, and whatever you pass in will need to know how to do it, and I will use it in my function here. And likewise, when we actually go to playing the rounds, we can tell it how many rounds we want to play. and then it basically just loops through and picks some random players and makes them battle against each other. And again, the implementation of this game doesn't really matter. What's key is that, again, through dependency injection, we are using all these things that we injected at instantiation time or construction time. So we keep using the logger, right? See, the logger debug is how we're printing anything out in this game. And likewise, whenever we need to actually get something from our database, we just call c.db.getName, because we dependency injected, or we injected pointers to these other two services or components or packages, depending on how you look at it, that we can use at runtime. Now, in this Citadel game, if we go back to app.go, we can see a couple of consequences. So first of all, we need to instantiate. Everything needs to be ready for when we create the client, so that when we create the client, we can pass it in valid pointers to things. Because we could, of course, pass in a no, right? Because we're just passing in a pointer. This would compile if we got rid of the stuff here, but it obviously wouldn't be very useful because our client would just crash, right? And say, I don't know what you've given me, but I can't actually use it for anything. It's no, right? So that wouldn't work. And likewise, the real power of dependency injection comes from the fact that you can separate things out. So by saying we're treating a logger separately, and we're treating a DB service, like this could be a database, a real database ORM or a real database connection, but by creating them separately, we can actually keep them as different puzzle pieces inside our application. So when it comes time to testing the client, for example, let's say we wanted to be good developers and we wanted to implement some unit tests for the client. Because they're unit tests, we wouldn't really want them to connect to a real database. Let's say our DB service connected to a real database under the hood. We don't want it to do that in unit tests. We just want to mimic the DB service. Because we've used dependency injection in the client, as long as we create something that lives up to the interface that the client is expecting, we can actually just create a bogus or a mock DB service that we can pass in at testing time. And then we can use that to run our unit tests and worry about what the client does and not worry about what this service does. And I think that kind of separation is really where the full power of the dependency injection comes into play, because you can neatly separate all your business logic into the different domain packages, and then you can bring them all together to create powerful applications when the time is right. But you keep them separate so that when you test them, you can mock different parts of the puzzle and make sure that what you're testing is actually behaving the way that the real thing might behave, right? Without actually having to worry about spinning up the real thing. In this little example, it's not that powerful because DB service just runs a in-memory map anyway. But most of the time, this would connect to a real database or to a cloud or something that you don't really want to do in a unit test. And so by using dependency injection with the consumer interface pattern, we can actually mock it and pass it in when we need to. So this was just a little introduction. Let's run a little game again to dependency injection in Golang. And it is really a first-class citizen in Golang. And it's something that you should be using in all of your Golang projects. So thank you for watching, and I'll see you in the next one.